All right, hey AP Chemistry. So I wanted to do a couple of examples in which you may be asked to identify subatomic structure. So let's look at this example of calcium. I just pulled this from our periodic table. So Ca is calcium. Here is this number on the top, which is 20. Remember, that's its atomic number. And as mentioned in a previous video or in your reading, this is equal to the number of protons. This is the symbol, and this is the average atomic mass. This 40.08. It is not the mass number, and it's a weighted average. So we're not really going to use this yet. We'll use this when it comes to the mass spectroscopy POGL. All right, so typical questions that you'll be asked, or just like a very simple question, is if, let's say I have calcium, and I know it has a mass of 40, it'll ask you, or a question will be asked for protons, electrons, neutrons, and then maybe even the symbol. Okay, so we know that the atomic number is equal to the number of protons. So calcium with the mass of 40 has 20 protons. It's not charged, it's not saying it gained or lost electrons. The number of protons is going to be equal to the number of electrons. So that's also 20. Okay, so just remember, electrons for a neutral atom, neutral, meaning no charge, equals the number of protons if there's no charge. Okay, and then for neutrons, it's going to be our mass minus the number of protons. And so in this case, it'll be 40 minus 20, again, where all of them is the same. Okay, I'll jump up over here. If I have calcium with a mass of 40, the number of protons will be 20 still. The number of electrons will still be 20. And the number of neutrons are going to be different. This has a mass of 41, and there are 20 protons. That means I must have 21 neutrons. Look at what is different between these two. They are the same element. They're both calcium, but they have a different number of neutrons and therefore a different mass. We call these, as mentioned before, isotopes. Isotopes are the same element, but they have different masses because of a different number of neutrons. And then the way that I would write the symbol, I would do 40, 20 Ca, or I could just say 40 Ca, or I could just do 41 Ca, 41 20 Ca, or 41 Ca. Remember, sometimes you might not see the atomic number on the bottom because it's assumed that it's a 20. I'll jump down here and do bromine a bit quickly, or if you want to pause the video and try and do bromine on your own, you could do that now. And I'll ask you the same thing. How many protons, neutrons, and electrons does bromine with a mass of 80 have? How many protons, neutrons, electrons does bromine with a mass of 79 have? What are both of these called with respect to each other? How do I write the symbol? So if you want to pause the video and try and do bromine on your own, you could do that now. Otherwise, I'm going to do it. For protons, you could check your answer. Protons is going to be equal to 35 because that's our atomic number. Electrons is also going to be 35. For the number of neutrons, it's going to be our mass minus the number of protons. If I do 80 minus 35, I get 45. And if I want to write the symbol, it'd be something like bromine 80. Or you could do 35 at the bottom if you wanted. And then over here, same thing. Protons are also going to be equal to 35. Electrons are 35. And the number of neutrons, it's one less mass, so it's going to be equal to 44. And again, if I want to write that symbol, 44 is going to be 79 over 35. The only difference between these two are the number of neutrons, and we call these isotopes of each other. So bromine 80 and bromine 79 are isotopes of each other. They're both bromine. They just have a different mass. Alrighty, hopefully this video was helpful to kind of give you a bit of insight of what I want you to know how to do in the beginning of chapter 2 and for the mass spectrometry POGL to understand.